All right, everybody. Thank you for joining us. We've got a great webinar planned for you today. Today's focus will be on the quantum computing threat and what that means for your organization, specifically the telecom industry. And we'll go into, more importantly, what organizations can do for themselves and for their clients to start protecting themselves now and remain compliant for quantum resilient standards in the future. For those of you who have been following this market somewhat, you know that this transition to quantum resilient cybersecurity is likely to be the largest upgrade cycle in technology history. And we'll go into why exactly that is, but what you'll find is that quantum computing will compromise all of our public key infrastructure that secures 90% of our data traffic. And again, for those of you who have been following this market somewhat, you'll know that the government, the US federal government, passed a law last year that is mandating federal organizations to start preparing for this upgrade, planning, inventorying their cryptography, and then laying a path forward to how to upgrade to post-quantum cybersecurity. We here at QSecure serve both commercial and government organizations, aiming to help them ease that transition so that they can upgrade to meet quantum resilient standards without having to rip and replace their existing systems, and so that they can remain safe and compliant for the future. Without further ado, I'm going to go ahead and introduce our two speakers for today. We are joined by two of our co-founders, Rebecca Krauthamer, who is our Chief Product Officer. She is a Forbes 30 under 30, serves on the World Economic Forum, and has won multiple awards for her stellar work in the industry. If you know her, you know she is the best and the brightest of the bunch. And not to be outdone by Dr. Garrison, who is our Chief Strategy Officer, and absolutely brilliant. And so these two are going to give you a laydown of the quantum computing threat, how your organization can start preparing for this transition, and hopefully we'll show you a little bit of how that's done with a live demonstration. And at the end of the webinar, if we have time, we'll do some Q&A as well. So please stick around. And with that, Becca, over to you.
Thank you, Pat. Hey, everyone. Welcome. And if you go to the next slide. We can't talk about post-quantum cybersecurity without first talking about quantum computing. But at this point, most people know the story of the ones and the zeros, so I won't go into that. But when I first started in quantum computing, I came from the world of AI, and when I first started, we were in the space of investing in and building quantum algorithms. So I know well the opportunity in the world of quantum. And there's so many cool things that we can do in quantum. And I tell everyone, you know, we're in like the 1970s of quantum computing. And we're here today to talk about the opportunity of post-quantum for telecom, but I think it's important also to talk about the opportunity for quantum. If you think back to the 1970s, there were so many companies that are now the Fortune 10s and 50s of the world. And so investing in those organizations that are coming up in the ecosystem, huge and incredible opportunity. And you don't just see this in private investment, but you see this in public investment. So there's over $30 billion that we know about publicly that have been invested in quantum computing advancement because there's so much potential. There's so much potential for good. And of course, conversely, and this is how I came to this space, understanding the quantum algorithm side for good, but also what you could do to weaponize quantum computers to decrypt our current encryption standards. And so when we first started talking about this back in, let's say, 2019, we had to convince a lot of people that this was an issue. Now everybody understands it. There are literal Netflix movies about this, right? So the drive for organizations to make this upgrade are coming from consumers of products, and I think that's part of the opportunity we'll talk about today. It's also coming from the government side. And so Congress has put the US has put a lot of money into quantum development, but it's also passed laws in the last couple of years that mandate upgrades to post-quantum encryption. And as we speak, there is the 5th annual NIST conference on the standardization of PQC happening this week in DC. And so that's very exciting. And with that, I'll flip over to the next slide. So to take a bit of a step back, we know about the quantum threat, but it's not one that we have to be scared of. It's just one that we have to be proactive about. And the good news about this threat, while it is potentially catastrophic, it does, as Pat was saying, affect all of the encryption we know and love for data in transit. And that's data as it travels between points. The good news is that we have fixes. And so organizations just need to implement and adopt these new standards in order to make the data that they steward, the data that is under their realm of control, quantum safe or post-quantum protected. And I'll point to a picture, the picture on the left of this slide. So this is a picture from today at the NIST conference. And this conference is a big deal this year. This year, 2024, is when the final post-quantum cryptography standards come out. And so it's no longer, oh, we can wait and see. As of this year, the previous standards that we used for encryption are now obsolete. And what is the new standard is post-quantum encryption. And so it's being demonstrated here in this picture. This morning it was demonstrated on the White House lawn, and here you see it at the NIST conference. This is a project that we did in partnership with Accenture, as well as a Fortune 100 telecommunications company. You know this company, it is a fantastically forward-thinking company, and you probably can't read this, but it is saying, testing, hey, and this is back and forth between all the parties. We are live chatting on a post-quantum encrypted 5G chat, and one chat says, I'm using Kyber with a specific key length, Kyber being one of the post-quantum cryptographic algorithms. Next chat says, okay, now I'm using HQC. This is another of the post-quantum cryptographic algorithms. And so this is a very, very cool demonstration of not just post-quantum encrypted 5G chat, but this is also the ability to switch algorithms, which we call cryptographic agility, which is a huge, huge key piece of making this post-quantum upgrade. So what we see, this is the, I think they call it the racing chart, right? This is not everybody has to make this upgrade immediately, but we are in the business of protecting data that cannot be leaked. And so the industries that have traditionally cared most about this upgrade cycle are insurance, public sector, and banking. But we're here today because what we've seen in the last 9 months is that Telecom has really started making this move to be the leaders in making this post-quantum cryptography adoption. And I think this is in large part because Telecom has really been an early adopter of quantum safe technologies. They've been for years experimenting with something called QKD, or quantum key distribution. And in the last year or so, what we've really seen is that as the post-quantum cryptography, again, these algorithms being things that we know and we can use today, they're just classical algorithms to fight quantum threats. As these become standard, Telecom has been launching more and more into adopting these algorithms as well as cryptographic agility in order to get these protections out everywhere they need to be. Next slide, please. So to bring it back to QuProtect, and I get the privilege of leading product here at QuProtect. And what we set out to do was make this upgrade cycle, again, potential $1 trillion upgrade cycle. Everyone has to do it at some point. Make the easy button for that upgrade cycle. A lot of people still think that they have to wait years and put in millions and millions into this process. And that is no longer true. We can turn that process into a matter of days. The previous chat that you saw on the previous slide, that specific deployment took a matter of hours. So what can we do with this? We enable you to leave your existing encryption in place. We also enable you to hot swap with that cryptographic agility. All the NIST finalists, these are the new standards. So you're never caught flat-footed with an encryption algorithm. Again, I can't emphasize how awesome this is. Ask your IT people if you're not already aware. But without taking down your applications, or your services. You can change out the encryption, you can change out the key length, you can change out the key rotation frequency. And it is a fantastically beautiful thing because that's not done before. And all of that together, that makes QuProtect, which Garrison is gonna show you a little bit of today. Next slide, please. So to wrap up my piece, we have some fantastic partners. We work a lot with direct customers in the spaces that I've mentioned. A huge sector that's quickly growing is telco. And we often also work through partners. And so we're very close with Accenture, Amazon, Caresoft, Red Hat, and a number of others. So whoever your chosen partner is, whoever you know and trust, we can come in through that vector and help make this upgrade cycle simple. We do it a lot through cloud migrations, making those cloud migrations post-quantum encrypted. We'll do it through zero trust rollouts, right? So post-quantum is not something you have to overhaul your entire systems for. It's not something you have to have a multi-year roadmap in place for. Absorb it in the manner that is most effective for you. And I'll quickly talk about the way that we get out to all of the different, again, data in transit or data in motion. Anywhere data travels, that is what's at risk. And so we have several different, we have three in particular different ways. One, we can protect applications. So this is your mobile apps, your web applications. You saw an example of a 5G chat application. That's exactly how Apple iMessage is upgraded to post-quantum. If you update your iOS, you should be able to get access to post-quantum encrypted iMessage pretty quickly here. And then we have network, what we call network, and that's application to application. So that's service to service, how you get between applications and to share data between those. And what Garrison, I'm going to hand it over right now to Garrison, what he's going to talk about is what we find the telcos most interested, their starting place. And this is something that we call core, and it's for core networking. And it's router to router communications, or you could call it site to site VPN. And so with that, I will hand it over to Garrison to talk a little bit more about that and show you a live demo.
Realized that I was muted. My apologies. Yes, thank you, Becca. And here today to talk about post-quantum for MACsec and IPsec transport. Next slide, please. So as Becca had alluded to, we have a number of products that are available on our QuProtect platform. And today I'm going to be speaking to you about QuProtect Core, which is the ability to protect IPsec and MACsec as transport protocols. These protocols typically form the backbone of a lot of core routing infrastructure. So these, again, are IPsec tunnels or site-to-site VPNs that you'll use in order to connect, for example, an on-prem colocation to somewhere in the cloud, different colocations to one another, or even multi-cloud setups or cloud-to-cloud, basically any configuration that you can imagine there. These are all typically facilitated with IPsec. So too, MACsec is actually a layer lower, and it allows for higher speeds and encryption being done at a lower level. This is, again, a somewhat similar technology that service providers often leverage. For example, you can see here AWS DX or the Equinix Fabric as examples of folks using MACsec. Again, right, the kind of speeds and throughput here are orders of magnitude apart, but they operate in a conceptually similar way. Next slide, please. And as Becca, again, had mentioned, right, early on, there was a lot of demand from government and financial institutions. And over the last 3 months or so, we've seen a lot of interest from telecom. So telecom, right, whether it's looking at those kind of 3 different products, whether it's application to application or web application out to the edge, or even for their core, we've been getting a lot of interest. And so that's the impetus for having this webinar, which is to talk about, right, what the networks can do today in order to upgrade themselves in a really simple and low risk transition way from their existing encryption to post-quantum. And with our system, we actually allow you to do this again without any disruption to your current operations. We allow you to instill post-quantum protection with, again, very low risk to upgrade between all of those links and enhanced telemetry and visibility over your routing infrastructure as well. So here you're able to see just a kind of a couple of examples of what you might do with our core technology. Here we have core network management. So again, this is router-router communication. You may be doing that right within your core network. This could be, for example, different data centers or colos connecting to one another. And you can also think about mobile networks that are routing again over, for example, major telcos' core infrastructure. Next slide, please. So really quickly, just to kind of take a step back and say, here's what we do at a technical level for QuSecure. On the left, today you're often on your own to manage your own cryptography, right? And this is true of whether or not you're managing servers here, right, with disparate applications or languages on them, right? You need to make sure that all of those are interoperable. You have the correct certs, all that sort of stuff. And we view that there's an opportunity, right, surrounding this upgrade that needs to happen with post-quantum to bring all of those devices into a homogeneous layer that you are able to control with a control plane from a centralized orchestration unit. And that's what you're seeing there as the eye diagram kind of just below the person. We view this transition as a very similar transition to what happened in the early aughts with disparate networking devices being brought into a homogeneous controllable space with SD-WAN. We're seeking to do that same thing, but for cryptography, and then again, providing all of that telemetry and control that you would expect. Next slide, please. So as Becca was alluding to, right, we have 3 different products that are built on top of our core, on top of our platform. Today, we're going to be talking mostly about core, but so too, right, we're able to provide not only connection between data centers, as you can see there on the bottom, but also from server to server, as you're seeing there with QuProtect network security, and also, again, server out to the end user device. This is what actually was deployed and what Rebecca was showing you earlier on the phone. Here, we're able to control everything through this centralized orchestrator that you see here at the bottom. This is a self-contained crypto system that doesn't require you to use any other piece of infrastructure. So you don't need to stand up another CA. You don't need to worry about interleaving PKI. We create, distribute, and consume all of our own keys, and you can modularly lay this over any existing communication link that you have today, whether it's encrypted. We will just subsequently re-encrypt that, and you'll have double encrypted. Or if you have text going across in the clear, we're able to upgrade that to best-in-class encryption today. All of this is done right from a centralized orchestrator with post-quantum algorithms that you can swap easily between, and we refer to that as crypto agility. Very good. Next slide, please. So applying that same framework now to how we would protect, for example, some of these routing devices. We again create, consume all of our own keys. That can be set at the level of policy via our QuProtect orchestrator and admin console. As you're seeing there on the top, you're seeing a very small view of that, and you'll see a slightly larger one in just a second. That is able to securely provide these keys, again, these are AES-256 keys, to a QSecure agent, which in turn can supply them to, in this case, a Cisco Catalyst 8000V Edge virtual appliance, and is able to upgrade that IPsec tunnel that exists between those 2 routers to post-quantum. Additionally, right, we're streaming back off of that telemetry to our administrative console, and we're able to affect the key rotation on those routers, down to the minute or the second, whatever you would like to do in order to increase the security on those routers. Maybe Brandon or Pat, if you'd like to read a couple of those from the chat, or even I can do that as well as we're coming in.
Yeah, absolutely. We've got one here from the chat asking about which routers are supported for the core product. So Garrison, why don't you take that one?
Yeah, sure. So today, right, we're looking at RFC 8784 for integration into those. What we've tested on is these the routers that you saw there, Cisco Catalyst Edge 8000Vs. Those ones are able to, again, support our platform, and we're able to get the telemetry from those. And we're working on testing additional routers as we speak. Like, anything else you'd like to add, Fallon?
No, I think that's there is a something called RFC 8784. What we support on Cisco routers is something called the skip protocol. It is proprietary to Cisco. However, RFC 8784 is something that is being more broadly adopted. So chances are, if you're not a Cisco user, whoever is your router provider is also doing something with that RFC and is also compatible with what we offer.
Wonderful. I think, Pat, if we go to that next slide, we're already on the Q&A. But maybe Pat, if you want to bring in one more question, and then I can try and share again and see if we've gotten those permissions fixed.
Yeah, absolutely. So we've got another one in the chat here asking about the performance. So maybe you can talk a little bit about how core impacts the performance on the routers.
Yeah, so, and sorry, Pat, maybe for this one, we want to go back one slide.
Yeah.
So what's really neat about this is that all we're doing is supplying the keys that are consumed by the routers. So in this case, right, all the synchronization is being done kind of on the routers themselves. We don't need to add anything else to provide this capability. This is a native capability to these routers. And so the performance actually remains exactly the same. And all that's happening here, right, is that you're getting, again, enhanced security and key rotation and telemetry off of the routers. It's a purely additive solution in that way.
Awesome. Becca, why don't you take this one? When are the new post-quantum standards going to be released?
Oh, this sounds exciting. Okay, so as I mentioned, the 5th NIST PQC standardization conference is happening right now in DC. NIST is the body that's been working on the standards since like 2016 to bring about what makes RSA obsolete. So this is the suite of post-quantum cryptographic crypto systems. And side note, the cool thing about this is we're in this situation because we based everything on one type of math, and that type of math turns out to be vulnerable to quantum decryption. Now NIST said, hey, let's not do that again. Let's base our let's have multiple new standards. So what they're doing is they've had a competition to find the best algorithms. They've down selected to a handful. And what is most likely to happen is that these algorithms are going to, a handful of them will become the new standards. And we already know what those algorithms are. Those are the algorithms that are supported in our system. And the idea is that they're going to be based on different types of math, so that if one should in the future be broken, right, quantum computing advances, AI advances, decryption techniques become more sophisticated. If once again we run into a situation where that math is proven to be vulnerable, we got backups. And so a lot of foresight for NIST, but also the reason why what we call cryptographic agility is really important. That ability to swap out the algorithms on demand, the ability to swap out the key links should you need heightened security in certain areas. So apologies for the tangent, but I think it's really cool. And it's really cool that this is happening right now. There's a lot of moving pieces, but essentially NIST kind of knows that the algorithms that it's giving its stamp of approval to. They're talking about that this week. Then there's the official process of the FIPS drafts have been submitted, yada, yada. Then becoming standards happens in the next several months. So the current estimate is that this will happen between June and July right now. That is the word on the crypto street.
Awesome. All right, we've got about 2 minutes left. I think we can do 1 minute on the last question here from the chat, and then we'll wrap it up and give you guys some contact information so you can reach out. So last question here, and I think this is a good one because it's an important topic. How is what you're doing different from QKD? And for the folks on the line, QKD is quantum key distribution. Garrison, why don't we give that one to you?
Sure, and I'll try to keep the answer tight here so we can get off on time. Essentially, right, we are providing a highly similar function to QKD, although QKD relies upon physical properties of kind of entanglement in order to deliver, right, the security. So the security is actually a physical component of that system. For us, we provide post-quantum security, which is basically mathematical problems that are difficult to solve without having, right, the correct keys. So for us, right, we're very similar to how you enjoy encryption today. So when you go to your bank and you see that lock in the corner of your screen, right, that's all software encryption that's being done. We provide, right, that same software encryption just to a new higher security level and in a version that's going to be resilient against quantum computing.
Awesome. All right. That brings us to the end of our webinar, folks. Again, contact information is on the screen. If you have any questions about what you've heard today, or you'd like to schedule a live demo, or just talk further about the quantum space in general, we're all yours. Contact information is there on the screen. So thank you all for joining us, and we look forward to hearing from you.